Hey everybody, here we have two power supplies. These come from my uncle. One on the left is a nice Overbuilt Hipro 250 watt power supply, and the one on the right is a deer roast. It's actually an Allied AL8300 ATX 300 watt power supply, but I'm calling it a deer roast for a reason. You'll see why in just a minute. And of course, those Allied power supplies are pretty much a branch of the Deere power supply manufacturer. So let's go and have a look at it first. You're going to see exactly why I'm calling it a deer roast, because it got roasted very good. Let's go and have a look inside it. Okay, here's a closer look at the deer roast. We're going to take the cover off. This one got cooked very good. Now, of course, on the primary side, you really can't tell too much. Primary side looks just like it normally would. We got some Gen Con capacitors, two primary caps, 470 microfarad, 200 volts. I'm pretty sure those are probably legit. They look like they're 470 microfarads in terms of the size. They got good size to them. Got a good beefy bridge rectifier there. Very thick. Not sure what the rating is. Let me go and get my flashlight. It's probably a 6 amp. I'm not sure. This is a let me see, might be a 4 amp. Not really sure. Even if it's a 4 amp, it would be enough for a 300 watt power supply, but usually you'd want to find probably a 6 amp in there. But what's funny is you notice how the board is silk screened for the 4 diode treatment, but they basically bent the legs on a bridge rectifier to plug into the holes, which if you have a look here, you can see how this is done. So that way, if you have a cheap power supply you want to upgrade, you can take out those 4 puny diodes and put in a real bridge rectifier by doing this method here. Anyways, this power supply has what appears to be a complete filter stage, EMI filtering stage. We have 2 X caps, 2 coils, a total of 4 Y caps, and when you consider the ones on the little PCB here and the actual main board here. We have MOVs. They're back behind the 2 primary caps. These are here for surge protection. This power supply, I believe, uses a half bridge design by seeing that giant dipped red capacitor there. That's what I found online anyways. We have 2 main switchers. These are TT2146 switching transistors. And on the left we have our 5-volt standby, which is a CET. Let me grab a paintbrush so I can clean that off so I can see better. It is a CET okay, CET, what appears to be 4225. Number under that is CEE U2N6. Anyways, let's go and move on. If you look to the back side, you can actually see the main transformer is pretty good sized. Looks to be like a 35 size transformer. Not really sure. Just looking at the numbers on the top of it. Good size transformer, good size heat sinks. The 5-volt standby and feedback transformer are decent sized. The ones on low end power supplies are usually half that size. Now let's go ahead and head over to the secondary side where you'll see all of these scorch marks on this thing. This power supply has been heavily loaded. Almost all the secondary side caps are bulging. These are YC, or I think Yang Chun or something like that. Had the little Saturn logo on them. We also have some caution capacitors, those green ones. One of those are bulging. We have a somewhat decent sized inductor there. 3.3 volt inductor is adequate. We got, I think, 3 or 4 pi filters in there. But just have a look at this PCB, how scorched dark it is. This power supply has run way too hot. And this power supply is a 5-volt heavy design. Even has a minus 5-volt wire, so this thing is in the past. Just gonna look at the label so you can see. I normally do that first thing, but I kind of forgot to in this video, so anyways. There's your specifications. Pause of view specs. You notice right away it's got a lot more power on the plus 5-volt rail than it does a plus 12-volt rail. A lot of even 650-watt power supplies today have less amperage on the 5-volt rail and 3.3-volt rails. Most of that power on modern day power supplies is on the 12-volt rail where it's needed. That being said, this single is indeed powering a 12-volt oriented system. My uncle was pretty short on power supplies, and he had that many. And this is probably the best one he had to run his Athlon 64X2 4200 plus system. He was running onboard graphics, I think probably 2 hard drives, 1 or 2 optical drives, onboard GeForce 8100 graphics, full size ATX motherboard. This thing is being pushed pretty hard in terms of the 12-volt rail. Now that's one reason I think this thing has failed. I mean, the thing actually still works, I believe. I haven't bothered to test it though. My original intentions were to just recap it, but not after seeing this. Though I did see somebody on Bad Caps take a Delta that got heavily burned from a seized up fan, recapped it, and still used it. Anyways, here's the second reason why I think this power supply got so hot. Was simply because of the fan control circuit. The fan still works. I mean, I can spin it just fine. Now I'm not sure if there's a connection going to it or not because I haven't bothered to test it. But if you have a look here, this thermistor, little green thing next to the 3.3 volt inductor, is pointing toward the inductor and not actually toward the heatsink. In many power supplies, the fan control sensing thermistor is actually attached to the secondary side heatsink to monitor the actual temperatures. And these particular allies are known to run the fans at very, very low speeds. The older allied units, like this one here, seem to run the fan at a higher speed. That's the first gen AL-A300 ATX. It only has a 10 amp 12 rail, or used to. That was before I replaced the fast recovery diode in it with a 20 amp Schottky. But anyways, we have to look here. This thing just has got heavily scorched. And I took some pictures. I'll include the pictures I took of this thing, so that way you can see better than what you're seeing in the video. But yeah, those caps have definitely had it rough. I'm sure there's a lot of ripple on the outputs on this thing. And have a look at this. I took the fuse out earlier. The fuse is a 5 amp fuse. You notice the silk screening on the PCB states that for 1A through 235 watts, use either the 5 amp or the T5AL. This thing had a 5 amp fuse in it. Now I'm not sure whether this thing was actually built for 235 watts or, because I mean they can take a PCB and pretty much put anything they want to on it. But this is just something to note. The fuse was good actually. The fuse was still, it wasn't blown or anything. Anyways, there is the chip of the year 2003. That is I believe it's a supervisory MPWM all-in-one. Not 100% certain though. I haven't bothered to look up a data sheet, as those can be hard to find for proprietary chips like that. Anyways, if you have a look here on the secondary side, have a look here. Let's see, 5 volts is next to the ground. You have 12 volts here and 3.3 volts next to that. And just while we're on that subject, look how dark those wires are, especially around those diodes. They got extremely hot. Even the plus 5 volt wires have gotten where they're starting to turn black on the insulation at the bottom. Even the wiring of this thing has gotten hot. So on the left we have an S30 D4OC. I'm assuming that's a 30 amps, probably a Schottky rectifier. And I'm assuming that's for the 5-volt rail. And a little bitty STPR1020CT. I'm hoping that doesn't mean 10 amps. I'm hoping maybe it was possibly a 20 amp part, but still, it appears to have gotten really hot. Because you look at that versus the other two, you see how it's not black, it's actually more of a lighter color. It appears to have gotten pretty warm. The one next to that is another, let's see, I'm not sure if all three of these parts are MOSFETs or not, but on the right we have an S16C40C. Now, judging by this, it appears that the 3.3 and 12 volt parts, or at least the 3.3, is overrated. I'm assuming since the 12 volt wires come out in the center, the part in the center is a plus 12 volt output, and I have to get the light on just right to be able to see the model, because it's, there we go, it's STPR1020CT. So that's just barely there, if it's a 20 amp part. Because I mean the plus 12 is rated for 15 amps, peak 18 amps. But yeah, just want to show you this. As I mentioned earlier, my original intentions were to open this and recap it, but I'm not going to be doing that. I'm just going to go ahead and part it out. I've recapped quite a few of these and they've proved to be pretty reliable. But this one here has just had it too rough, so I'm just going to go ahead and part it out and use the parts out of it. Now I'm going to look at the Hipro. Before I actually move on to the Hipro, let me go and show you some pictures of this deer roast. Now that you got to see some pictures of that deer roast, let's go and have a look at this Dell Hipro. This is a Hipro power supply manufactured for Dell. These are commonly found in many Dell Dimension computers from, I don't know, 2003, 2005, something like that. You'd either find these Hipros, or you'd find Newton power supplies. Those were the two common ones in these computers, and this thing here is built very nicely. It's not one of the passive PFC models, but still is built very nice. It's got a lot of weight to it. Now before I pop the cover off, I'm just going to look at that label. Here's a look at the spec label. Pause to view specs. As the way it is with me Hipros, they tend to be underrated because they're overbuilt so well. For example, I got a Hipro unit up there. It's a HP D3057F3R. These are known to have bad caps sometimes, but once you recap them, they're very reliable. These can actually put out 350 watts, no problem. And they can actually put out 400 watts, but they'll overheat. But they don't actually burn up, they just overheat and cut off. But they can put out 350 watts, no problem at all. That being said, it's going to take the cover off and have a look inside. And the whole PCB just decided to lift up for some reason. Strange. That's the only thing I don't like about this. When I tried to lift that cover off, the whole PCB just lifted up like this. And so it's only being held in with 3 screws. There's no hole there for the 4th screw. I've seen another Dell power supply like this before too, but it's usually not too much of a problem, but that is concerning because this power on signal hookup is only about 2 centimeters away from the neutral side of the AC plug. The neutral side anyway, but I'm going to start by looking at the primary. This thing is built very well. Got large caps in there. Not the best brand, but good sized capacitors. And look at the filter stage. This one does not have anything on the receptacle. It is all on the PCB. So we have 2 Y caps there, and I believe that's also a larger Y cap. I'm not 100% sure. That might be MOV, seeing how it's sleeved. Usually they'll sleeve MOVs, but the MOVs I know are down here. There's one right there, and the other one is somewhere back there. It's actually behind. Oh, it's actually in between the bridge rectifier and this cap here. So there's one MOV, other MOV is back there. This is what I believe might be an 8 amp bridge rectifier. It's a GBU 8J. Anyways, we've got this massive long filter coil here and a smaller coil next to it. There's an X cap here, and there's another X cap there, and there's an NTC thermistor right there, inrush current limit thermistor. And the fuse is held in by the fuse is replaceable. It's not soldered in. Surprisingly, that Deer was the same way, the Allied unit. But anyways, moving on here. Get my flashlight so you can see the primary side better. There's the main switcher. I don't think this is a half bridge design. I think it's a little bit different. I don't see that big dipped capacitor back there anywhere. Though I'm not 100% certain because I'm not an expert with power supplies identifying whether they're half bridge or I think 2 transistor forward or single transistor forward or whatever. 5 volt standby control is, I believe, on that IC right there behind the little add-on board. Get you some better focus. There's the add-on board. It's got another IC on it, so that IC on that add-on board might be the 5 volt standby IC. This is definitely not a 2 transistor design. Got decent sized transformers for a 250 watt power supply. And here's something I see really strange. I've never seen this before in a power supply. The secondary side rectifiers are mounted onto a PCB that itself is actually mounted to the secondary side heatsink. There's the secondary side rectifiers. I can't really identify which one goes to which rail. I see one of them is a STPS 30H. I'm assuming that's a 30 amp component. And the one next to it is a D83-004. That is a 30 amp component. And down next to it is actually a component that's actually mounted to the main PCB. That may be for 12 volt output, not sure. I think these are all Schottky rectifier components. I can't see the rating on the third one, but seeing it's pretty large, it means it's probably a 20 amp more component. Not too bad for a 250 watt power supply. Look on this side of the heatsink, the fan control thermistor is actually mounted right to the heatsink. That's the way you want it. Thing's got a massive coil. Secondary side inductor is much larger than the one in the Deer. Secondary side is also TPO in terms of capacitors, but none of them are actually bulging. All the caps look good in this one. Now I'm wondering if this thing possibly has DC to DC conversion for the 3.3 volt rail. There's no 3.3 volt inductor that I see anywhere, and we have Well, it looks to be a MOSFET there, possibly for it's probably a voltage regulator for 3.3 volts. So this thing may have DC to DC conversion, though I'm not sure. If you look at the size of heat sinks on this thing, are huge. Those primary caps are 560 microfarads. That's very well overbuilt for a 250 watt power supply. Usually you'll find 470 microfarad caps on a 250 watt power supply. And I'm going to show you the back side. Why not? Thing is built like a tank. This is a general idea of Hipro quality, and that controller chip in there appears to be proprietary for Hipro. It's got an HP on it. It's a HB1001WA, probably a supervisory chip. Not 100% sure. But anyways, there's a look at a good quality power supply. This is a 250 watt Hipro, and of course you got to see a deer roast. So anyways, well, before I finish this up, I'm going to just look at these connectors. Now the deer surprisingly had, I believe, all 18 gauge wiring on almost every connector, with maybe exception of the ATX 12 CPU connector, but this power supply has a mixture of 16 and 18 gauge. The 3.3 volt wires are 16 gauge. The rest of it appears to be 18 gauge. Have plenty of connectors for a 250 watt power supply of its time. No SATA connectors because this is a much older power supply. We have 5 Molex connections, a floppy connection, your main 20 pin connection, and of course the P4 ATX 12 volt connection. And this power supply does not have a minus 5 volt rail, so it's actually more modern in time than the deer was. So anyways, so you got to see a high quality Hipro and a deer roast. So anyways, have any questions or comments, feel free to ask, and thanks for watching.